Hello everyone to a NumPy tutorial for beginners series. This is the first video in the series, and in this video I'll be going through how to install NumPy and how to create arrays in NumPy. So to install NumPy you need to ensure that pip is working, and you can check this by typing pip list in your terminal. And if you get a table like output, that means your pip is working correctly, and next you need to type in pip install NumPy, and then you have to press enter to install NumPy. Since I've already installed NumPy, I won't be doing it over here. If pip is not working for you, that means you haven't added Python to your path, and when installing Python you need to click on the add Python 3.7 to path checkbox. If you want to know more about how to install Python, you can watch my video on how to install Python in Visual Studio Code to ensure that pip is working correctly in your computer. So once you have installed Python, we can start on how to create arrays in NumPy. So over here what I've done is that I've created a simple NumPy array from a Python list. And you can see that a NumPy array has been printed out starting from 1 all the way to 4. So what happened here is that the Python list has been converted into a NumPy array. So the reason why you would use NumPy arrays over Python list is that NumPy is coded in C and Fortran, which runs much faster than Python. So to speed up your program, it's better to use NumPy arrays than Python lists. So after creating a NumPy array, let's go through some important properties of NumPy arrays. So firstly is the shape, and this gives us the shape of our NumPy array. So there are 4 elements in the array, so we have a 4 here, and the shape is in fact a tuple, which will contain more numbers if we use multi-dimensional arrays. So next is the number of dimensions, and the number of dimensions in this array is 1, since this is a one-dimensional Python list. So next we'll talk about data type. So in NumPy, since NumPy is coded in C and Fortran, C and Fortran have many data types, and for example int32, int64, float32 and float64, which are the common data types. There are many more data types, but in this video we'll only be covering these 4. And when you're using NumPy, you need to specify the data type that you're using. So the data type of our array is int32, since these are integers. And if you want to create a float NumPy array, you can simply make one of the values of a Python float, and this will become a float 64. So next we'll go over array size. So what size does is it gives us the number of elements in our NumPy array. So there are 4 elements in our NumPy array, so that's why we get 4. So finally we'll print out a.n bytes. So we get 32. So this is the number of bytes that our NumPy array takes up in our computer's memory. And when you're working with large NumPy arrays, this might be an important property to look at. So next, let's go through multi-dimensional arrays. So list within lists can be made in NumPy, and a nested list must not be ragged. So the number of elements must be equal to each other so that you can make a NumPy array. So a few examples of ragged lists which cannot be used in NumPy are these 2 lists. So we can see that the number of elements in the first sublist is 2, whereas the number of elements in the second sublist is 1. So since the number of elements in each sublist is not equal to each other, this is a ragged list. Next we look at this list. So the number of elements in this list is 0, then 2, then 4. So since they are not equal to each other, this is another example of a ragged list. So examples of valid NumPy lists are these. So we can see that there's the 2 elements in this sublist, and there are 2 elements in this sublist. So since they're equal, this is a valid NumPy list. and the number of elements in each sublist over here in all three sublists, the number of elements are 2, so this is also a valid NumPy list. So to create a multi-dimensional list, all you need to do is to create a multi-dimensional Python list. And let me just copy the code here and I'll run it. And you can see that NumPy has formatted our two-dimensional Python list nicely. So you can see that it's in a table format. So the shape of our NumPy array is 2 by 2. So there are two sublists within our main list, so that's why there's a 2 over here, and in each sublist there are 2 elements, so we get another 2. So our data type is int32. Number of dimensions is 2 since it's a two-dimensional list, and 2 also comes from the length of this tuple. So that's another meaning for number of dimensions. A dot size, again there are 4 elements in total, so we get 4, and the number of bytes is 16. So let's go through one more multi-dimensional list, Python list. So over here we have a multi-dimensional list. So in our main list there are 2 sublists. So this is the first sublist and this is the second sublist. That's why there's a 2 over here. And within each sublist there are 3 more sublists, so that's why there's a 3 over here, and within that inner sublist there are 2 elements, so we get 2 elements, so that's why the shape is 2 comma 3 comma 2. So the data type is again int32. Number of dimensions is 3 this time because it's a 3-dimensional list, and again the length of our shape tuple is 3, and the size is 12 because there are in total 12 elements, and number of bytes is taken up by the NumPy array is 48. So now here are some additional methods to generate arrays. So to create an array full of zeros, what we can do is we can use the NumPy zeros function. So we have to input the shape of our array. So again, one more time, there are 2 sublists within the main list, so that's why you have to type in 2, and the 3 elements within each sublist, so that's why we write out 3. So that's how to create an array full of zeros. To create an array full of ones, we need to replace the zeros with ones. Let me run that code again. So we get an array full of ones. And you can also change the data type. So let's use integer this time. So now you don't see the decimal point anymore, so that's why we get an integer. So yeah, you can change the data type if you like. So next we'll talk about NumPy arange. So in Python there is the range function, and arange works very similar to the range function, and you can specify the start, stop and step values. So when you put in only one argument, so what arange does, it starts from 0 and it increments by 1. So you start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It doesn't go, 10 is not included in your NumPy array. So if you put in another argument, let's say I put in 5, what it does is that the 5 is the start value and 10 is the stop value. So we start from 5 and go all the way to 9, but not including 10. And finally is the step value. So that's when you add in 3 arguments. So let's say my step value is 2 instead of our usual 1. You can see that it starts from 5, then it increases by 2 to 7, and increases by 2 again to 9. So we got the odd numbers here. You can replace this with 1, and then we start from 1 and then 3, 5, 7, 9. So these are the odd numbers. You can also start from a higher value, and you can put this as you can put the step as a negative value. So you start from 10, then you decrease by 2 to 8, then to 6, 4, and 2. Again, you don't include 0 itself. And finally, you can also do decimals. So you start from 1, then you go to 0 0.9, 0 0.8, 0 0.7, all the way to 0 0.1. So that's how the arange function works. Next, we can use the Linspace function. I believe it's pronounced Linspace. So what you need to do is that you need to start from a value like, let's say 5, and then go all the way to 10. And then what you need to do is that you need to specify the number of values that will be in your array. So let's say I want only 3 values, and then let me run the code. So you can see that it starts from 5, then it goes to 7.5, and then 10. So this time it includes the stop value, and there are 3 elements in our array since we specified 3. So you can also change this to 4 and run the code again, and this time we have 4 elements within our array. We can also start from a different value like let's say 15. So we start from a higher value, and then we decrease. So we start from 15, then we go down all the way to 10, and then there are 4 elements, and you can once again change this. So now we have 5 elements in our list. So that's how Linspace works. So fine. So next we'll talk about how to make an array with the same value. So we have zeros and ones, but we can also, instead of having zeros and ones, you can specify which value you like using the NumPy full function. So what you need to do in the first argument is you need to specify the shape of your array. So over here we have a 2 by 3 array since we have 2 sublists within the main list, and then we have 3 elements in each sublist. And the second argument, you can specify which value you like. So since I've written 4, that's the value that would be used to fill up the NumPy array. I can also change this to, let's say, 9, run the code again, and then now my array is full of 9s. And we can also change the shape. Let me run the code again. Yes, so I get a 3 by 3 array full of 9s. Next, we'll create an identity matrix. So identity matrices are very helpful in linear algebra. So we can use the NumPy I function. So what the I function does is that it takes in one argument and gives us a square array. So it has to be a 3. So identity matrix always has to be a square matrix, and here we have a 3 by 3 matrix since we specified 3. And what an identity matrix basically is, that it is full of zeros except the diagonal values, which are full of ones. And then let's say if I want to create a 5 by 5 identity matrix, and you can see that I've created a 5 by 5 identity matrix. Finally, we'll create an array with random float values between 0 and 1. So what I can do is I can use this function np.random, so you have to write random twice, and let's print out. So here we get a 4 by 5 array full of float values between 0 and 1. So yeah, if you want to create a random array full of random values, you can use this function. So let's create a smaller random array. So here we have a 2 by 2 random array that has float values between 0 and 1. So this is it for this video. In my next video, I'll be going through how to slice and how to index values in your NumPy array. So thank you very much for watching this video, and please consider subscribing to this channel.